Well, in this video, I am going to show you how to take one trigonometric value and use it to find another trigonometric value. We'll be given a certain range for the variable theta. So, if we're given that theta is between 90 and 180 degrees, then that means that we are in the second quadrant. So the first thing is, let's draw ourselves a picture featuring the second quadrant. Now, so we're going to have an angle that goes out something like this. Alright, so there's our angle. However, this is the triangle at which we will be looking. So sine, when you first learned about triangles, you thought of it as opposite over hypotenuse. But in terms of circle, sine function is going to be the y value divided by the radius of the circle. So you can think of sine as y over r. Similarly, cosine is x over r, and tangent is y over x. Alright, so that means this is y and this is r. Okay, so think of the radius as 2 being right here, and the y value of 1, we can mark it right here. Now, secant is the reciprocal of the cosine function. So we're going to need this x value. So let's go ahead and do the Pythagorean theorem. All right, we're going to need this x value right here. So x squared plus 1 squared should equal to 2 squared, just doing the Pythagorean theorem. So x squared plus 1 is equal to 4. So x squared is equal to 3, subtracting 1 from both sides. So x is equal to plus or minus radical 3. Now we have to decide, based on the quadrant, whether or not this will be positive or negative radical 3. So this x value, because it is going to the left, will be negative. So this is going to be negative radical 3 for the x value. Okay, now secant is the reciprocal of cosine. So let's start off by looking at cosine. So cosine of this angle is going to be the x value over the radius. So the cosine is going to be negative radical 3 over 2. Okay, that will be the cosine. So therefore, the secant will be the reciprocal of that. So the secant is going to be negative 2 over radical 3. Now, if you want to rationalize the denominator, you can. You would just multiply the numerator and denominator by radical 3. So that would give you negative 2 radical 3 over 3. Okay, so that's the answer number 1. So let's see, let's take a look at number 2. First of all, we're talking about between 0 and pi over 2. So that is the first quadrant, so let's just draw ourselves a picture into the first quadrant. Okay, there you go. So here's our faithful theta right here. All right, now tangent is y over x. All right, in terms of coordinates. So that means the y value is 1, so I'm going to go ahead and put 1 right here. The x value is 7, so that 7 would belong right here. Now we're supposed to find the cosine, but for the cosine, cosine is x over r. So we're going to need this radius, so we will go ahead and find, we'll do the Pythagorean theorem. Okay, so we're going to do 7 squared plus 1 squared is equal to r squared. So that'll be 49 plus 1 is equal to r squared. So r squared equals 50, just flipped it around. So r is equal to, and normally we would say plus or minus the square root of 50, but the radius is always positive, so I'm just going to say square root of 50. All right, keeping in mind that 50 is 25 times 2, then r is going to be 5 radical 2. Okay, so this is going to be 5 radical 2. Okay, sorry, I don't like that 5. Let me try again. OCD. Okay, so that's my radius. So now I can do the cosine. Okay, so the cosine is x over r. So the cosine will be 7 over 5 radical 2. Or if I multiply by radical 2, that'll be 7 radical 2 over 10. So that's the final answer for number 2. So in problem number 3, the angle is between pi and 3 pi over 2. That is the third quadrant. So let's get that picture going. All right, this would be the third quadrant over here. Okay, so we are talking about theta going like this, and our reference angle triangle will be like this. Okay, cotangent. Cotangent is the reciprocal of tangent. So tangent is y over x, so cotangent is x over y. That means that 5 is the x value. Okay, so there would be like a 5 here, but wait a minute. This is going to the left, so this really needs to be a negative 5. And y is going to be 6, except for this has got to be a negative 6. Which makes sense because if we do negative 5 over negative 6, that's equivalent to positive 5 over 6, because a negative divided by a negative is a positive. But we will have to think of it as negative 5 over negative 6 because it is left and down. That's the x and the y. Now, we're going to need the radius in order to do the sine function, since the sine function is the y value over the radius. So we are going to do the Pythagorean theorem. Okay, so negative 6 squared plus negative 5 squared is equal to the radius squared. So the radius squared is going to equal 36 plus 25. Taking the square root of both sides, the radius is going to equal the square root of 61. Okay, so here is the square root of 61. Notice the radius is always positive no matter what. So now we are in a position to do the sine, which is the y value over the radius. Okay, so sine is going to equal the y value of -6 over the radius of radical 61. Now, if you really wanted to, you could rationalize the denominator by multiplying radical 61 in the numerator and the denominator. So that will give you -6 radical 61 over 61. Okay, I will accept either. So that's number 3. Number 4, this time we're between 0 and 90. That is the first quadrant as we draw our picture. All right, cosine is x over r. Okay, so this x goes right here, and the radius is 5. To find the cotangent, we're going to need this y value. So we will use the Pythagorean theorem. So y squared plus 2 squared is going to equal 5 squared. So y squared plus 4 will equal 25. So y squared will equal 21 once you subtract. So y will equal to plus or minus the square root of 21. Because this y value is up, then this should be a positive radical 21, not negative. Okay, so y is radical 21. And of course, this is the theta. So now we can do the cotangent, remembering that cotangent is x over y. So the cotangent of theta is going to equal x over y. So that's going to be 2 over radical 21. Or, rationalizing the denominator, 2 radical 21 over 21. All right, that's the answer for number 4. Well, number 5 falls between 3 pi over 2 and 2 pi. So that puts us in the 4th quadrant. So that's why I'm going to draw my diagram like this. All right, so here we are in the 4th quadrant. Cosine is x over r. So I'm going to put the 1 right here, and I'm going to put the 3 right here. We're going to need to find this y value, but notice that the y value is going to have to be a negative number because it is down below the x-axis. So this, whatever we find, this is going to have to be negative. Watch out for that. So we're going to do some Pythagorean theorem, of course. So we will do y squared plus 1 squared is equal to 3 squared. Boom, boom, boom. So y squared plus 1 is equal to 9. So y squared is equal to 8. Subtract 1 from both sides. So y is equal to the square root of 8. And normally we would say plus or minus. But this time we know it's going to be minus. So y is going to equal to negative. 8 is 4 times 2. So this will be 2 radical 2. So that's my y value, is negative 2 radical 2. Now that I know the y value, all right, this is theta, I can now say the cotangent. All right, because cotangent is x over y. So that's going to be 1 over negative 2 radical 2. Or rationalizing the denominator is going to be radical 2 over negative 4. So that is the answer to number 3. Did I say number 3? Number 5. Okay, number 6. This one is between pi and 3 pi over 2. So this will be in the third quadrant. So I will draw my diagram like this. Well, got a little skirt. Cosine is x over r, right? The radius. So the radius cannot be negative. So I'm going to look at this negative sign as going with the 2. All right? Negative 2/3 must be negative 2 over 3 since the radius has to be positive. So here's my x value of negative 2 right here. Here's my radius of 3 right here. Okay, so I need to find this y value, but keeping in mind, is this going to be positive or negative? This is going to be negative because it is down. It is below the x-axis, so make sure you choose the negative version when it comes to it. So here comes my Pythagorean theorem. So I've got y squared plus negative 2 squared is equal to 3 squared. So y squared plus 4 is equal to 9. So y squared is equal to 5 once you subtract. And y is equal to plus or minus radical 5. So in this case, we're going to do negative radical 5, like I said, because it's down. So now that I have the y, I can do the cotangent. Cotangent is x over y. Okay, so cotangent of theta is going to be x over y, so that would be negative 2 over negative radical 5. A negative divided by a negative is a positive, so I'm going to go ahead and put 2 over radical 5. All right, the negatives cancel out. Rationalizing the denominator, if you're into that sort of thing, would be 2 radical 5 over 5. So this will be the answer to number 6. Well, for problem number 7, we are between pi over 2 and pi. That's the second quadrant, ladies and gentlemen, so shabalao. We will draw our angle like soap. Okay, pi over 2 and pi. Okay, sine is y over r. So that means the y is 1. So there's your 1 right there. And the r is 3. So there's the r. What we need to find now is x. So I'm going to use the Pythagorean theorem. Keep in mind that this x value is to the left. So this is definitely going to be a negative x value. So we'll make sure we choose the negative version. So x squared plus 1 squared should equal 3 squared. So x squared plus 1 equals 9. Subtracting 1 from both sides, we get x squared is equal to 8. Taking the square root of both sides, we get x is equal to plus or minus the square root of 8. X is equal to plus or minus 2 radical 2. Like I said, we're going to need the negative version. So negative 2 root 2. Now, we are supposed to say what secant is. Secant is the reciprocal of the cosine. So cosine is x over r, so the secant will be r over x. So secant will be the radius divided by this x value. If we rationalize the denominator by multiplying the numerator and the denominator by radical 2, then we get negative 3 radical 2 over 4. So either one of these are correct. So first of all, the quadrant. The angle is between 180 and 270. So that is going to be the third quadrant. So that's going to be here, all right, between 180 and 270. So let's go ahead and draw that angle like this. Okay, so here is the angle theta. Okay, now I'm going to go ahead and make a triangle out of that so I can do the Pythagorean theorem if I need to. But cotangent is the reciprocal of the tangent function. So in terms of the coordinates of this point right here, cotangent will be x over y. Okay, so that means 1 is x and 2 is y, except for one thing. If I were to put, if x were 1, right, and I would have to put 1 right here for the x value, and if 2 were y, can you see why that wouldn't quite make sense? Hopefully you're seeing that, well, wait a minute, this is to the left, so this should be negative, and this is down, so this should be negative. So really this should be a negative 1 and a negative 2. And actually that would still make sense. Alright, if both of these were negative, a negative divided by a negative is a positive, so that would still have the same value as before. So I am going to look at these as negative 1 and negative 2. Alright, we are asked to find the sine function, so we will need the hypotenuse, alright, which is also the radius of the circle here, so I'm going to call it r. So that's going to be r squared is equal to negative 1 squared plus negative 2 squared. Alright, just doing the Pythagorean theorem here. So that means r squared is equal to 1 plus 4. R squared is equal to 5. R is equal to the square root of 5. Normally I would say plus or minus, but the radius is always considered to be positive. So I'm just going to say radical 5. Okay, so great. So the hypotenuse or radius is radical 5. So now I can do the sine. Okay, sine is the y value over the hypotenuse. Alright, the y value over the radius. So that's going to be negative 2 over radical 5. Or if I rationalize the denominator by multiplying the numerator and denominator by radical 5, that would make this negative 2 radical 5 over 5. So that'll be the sine of theta. Alright, looking at number 9. Between 90 and 180 degrees, that is the second quadrant. So we will draw our diagram into the second quadrant. Okay, like this. And here's my triangle. Now, tangent is y over x. So, and I see that it's negative, which means one of these is going to be negative. So let's see. This is left and up. So which one is going to be negative, x or y? Well, clearly the x needs to be negative while the y stays positive. So I'm going to look at this as positive 2 over negative 3. So there's my negative 3, and there's my positive 2. Now we're being asked to find the cosine, and cosine is x over r. So I'm going to need this radius here. Okay, so let's figure out what the radius is using the Pythagorean theorem. So the radius squared is going to equal negative 3 squared plus 2 squared. So that's going to be 9 plus 4. So that's 13. So that's square root of 13. Again, the radius is always positive, so I go straight to radical 13. So that puts me in a position to say what cosine is. Right, so this was the angle theta in question, but as I said, cosine is x over r, so that's going to be negative 3 over radical 13. Or if I rationalize the denominator, multiplying the numerator and denominator by radical 13, that would be negative 3 radical 13 over 13. So that is the cosine of theta. Alright, we're between 0 and 90. That puts us in the first quadrant this time. So there's my first quadrant. Okay, and I'll just make my triangle like this. Now sine is y over r. So that means this is the y value is going to be 6, and the radius is 7. And so that just leaves the x value that we need to find. Okay, we're going to need that x value. So that's why I'm about to do the Pythagorean theorem, which is going to go x squared plus 6 squared is equal to 7 squared. So x squared plus 36 is equal to 49. So subtracting 36 from both sides, I'm going to get x squared is equal to 13, and then taking the square root of both sides, I get x is equal to positive or negative radical 13. So since x is going to the right, I'm going to know that this will be positive radical 13, so there you go. Okay, now secant. Secant is the reciprocal of the cosine function. So keep in mind that the cosine function, so I'll just put this over here, cosine is x over r. So therefore secant is going to be r over x. Alright, it's the reciprocal of the cosine function. So that's why I'm going to do this. Alright, so the secant theta is going to be the radius over the x value. So that's going to be 7 over radical 13. Or if I rationalize the denominator by multiplying the numerator and denominator by radical 13, I get 7 radical 13 over 13. So that is the secant of theta.